In this lesson, we are going to talk about estimating the difference between two means and the difference between two population proportions. And in the previous lessons, we've only looked at estimating one mean or one proportion at a time. Now we're going to compare two population means or population proportions at the same time. And these methods that we're going to use in this lesson is specifically if the populations are independent. If they're dependent, that's going to be a whole nother situation that we're going to talk about later. So for this lesson, these samples and these populations need to be independent. Some concepts that you need to know. So I'm going to make a table here. If I have some number, I'll call it capital N. If this number lies between two positive numbers, let's say it lies between 1 and 7. So n is greater than 1 but less than 7. If the number lies between two positive numbers, then that number has to be positive if it's between two positive numbers. If I have the difference between two means or two population proportions, so let me put in here, make a note. This could also be for P1 minus P2. Then whatever is in between here, mu1 minus mu2 or P1 minus P2 has to be positive. And if mu1 minus mu2 and P1 minus P2 is positive, then the first value, the first population parameter in there has to be bigger than the second. So we're going to have the case that P1 is greater than P2 or mu1 is greater than mu2, depending on if we're looking at proportions or means. So if I had two numbers that were being subtracted and I know that the final result is positive, then the first number minus the second number, that first number has to be bigger in order for the result to be positive. If I have the difference between two population parameters as being positive, then that first population parameter has to be greater than the second. Now, if I had it between two negative numbers, let's say I had -7 and -1. So n is greater than -7 but less than -1. Then what that tells me is that n, that number in between those two values, has to be negative. So if I had -7 on one side of the inequality, and I had mu1 minus mu2 or P1 minus P2 in between the two numbers, then P1 minus P2 has to be negative, or mu1 minus mu2 has to be negative. And if it's negative, then that means the first number is smaller. So for example, if I had 3 minus 7, that's going to give me a negative number because the 3 is smaller. So in this case, we would say mu2 is greater than mu1, or I would say P2 is greater than P1. Now, if we had an example where some number lied between a negative number and a positive number, we don't know if that n, that number in between, is a negative or a positive number because it falls between the two. That n could be -5, which would be a negative number because that falls between -7 and 7, or that n could also be +5 because 5 also lies between -7 and 7. In this case, no conclusion can be made about which parameter is bigger. So when you look at this chart, I want you to think of this first column as your example to give you some concrete information to help wrap your mind around what's going on here. And then this gives us our actual rule that we're going to use. And this is our result or our conclusion based on what we have for our interval. When we create our confidence intervals for the difference between two population parameters, the procedure is going to be the same. We're still going to use our point estimate, and we're still going to add and subtract our error to find our confidence interval. The only thing that changes is how we calculate our point estimate and how we calculate our error. We're going to have different formulas because now we have two samples. All right, so if we're estimating means, then the point estimate is going to be x1 bar minus x2 bar. We're just going to take the two sample means and subtract them. That's going to be our point estimate. Then our error is going to be calculated by finding our z critical times the square root population standard deviation for the first sample squared divided by the sample size plus the second population standard deviation squared divided by the second size. Now this is the case when we know our population standard deviation. If I'm comparing two means and I don't know the population standard deviation, my point estimate is still going to be the same. It's going to be x1 bar minus x2 bar. But what's going to happen is I'm going to find my error by using t critical. And then instead of using my population standard deviation, I'm going to use my sample standard deviation. So this is if we don't know our population standard deviation for the two populations. Now in this case, when I find t critical for this, because we have two sample sizes, there's a very complicated procedure or a very complicated formula that we plug in all the information to find the degrees of freedom. So to find our t critical, we need the degrees of freedom. When we have one sample, what we did was we just took the sample size and subtracted one, and that was our degrees of freedom. There was no confusion with that. When you have two samples, like I said, there's a very complicated formula. And rather than use that complicated formula, what we're going to do is we're going to estimate the degrees of freedom by taking the smaller of the two sample sizes we're going to take the smaller of the two sample sizes and subtract one. Okay, so for example, if I had two sample sizes, one was 10 and one was 12, I look at the smaller of the two sample sizes, which is 10, and I subtract one, which would give me 9. So in the case that we're doing this by hand and you need to figure out the degrees of freedom, you can estimate it by using 9 in that example. Please keep in mind that that is just an estimate. When you see the degrees of freedom and you do it on the calculator, it's probably going to come out different because the calculator uses that complicated formula to figure it out. And that will give you the actual degrees of freedom rather than just an estimate. Okay, now, the last one, when you're comparing two proportions, the point estimate is going to be your proportion from the first sample minus your proportion from the second sample. Sometimes I forget to put my prime in there to indicate that it's coming from a sample. So if I forget to do that, just remember that the point estimate is coming from the sample, not the population. So just like before, we're going to add and subtract the error from our point estimate. Now to get your error, you're going to take your z critical times the square root of your P1, Q1 divided by your first sample size. And then you're going to take your P2, Q2 over your N2. Square root it and multiply by the critical value. Now, just like before, we need to make sure that in order to use that critical value from the normal distribution, we need to make sure that our sample sizes are big enough. And to do that, it's just the same way we did it before, only we have to do it for each sample. So I'm going to take the sample size and multiply it by P1 and check to see that that's greater than 5. And then I'm going to do that also with my Q1. And then I have to do that for the second sample as well. So I have to check all of these conditions are met in order to be able to use the normal distribution to estimate the binomial distribution. So before you find your Z critical, verify that these 4 items are true. So this is a rundown of all the formulas that we're going to need in order to do this by hand, but additionally I'm going to show you how to do this on the calculator. So let me write down those calculator methods as well. When we're looking at the difference between two means, and we know the population standard deviation, we're going to use the calculator function 2z interval, and that stands for 2 sample z intervals. If we don't know our population standard deviation, then we're going to use t interval, but we're going to do it for 2 samples. So we're going to do 2 sample t interval. And then for proportions, if we're finding the difference between 2 proportions, we're going to use 2 proportion z interval. So these that I put in green here are our calculator functions if we do it on the calculator, which I highly recommend that you do to try to save yourself all this arithmetic. But you should be able to do it a few times by hand just so that you can see how the calculator is determining this. So that's what I'm going to do in my next 3 examples for this lesson. I'm going to show you how to do it by hand, and then we're going to compare how it comes out on the calculator. In this first example, there's a discussion about Yellowstone National Park and how there were some major fires in 1988. And it goes on to say that there was some concern about the number of trout that it may have affected. It also goes on to say towards the bottom, and you can pause the video and read it if you want, but it goes on to say that before the fires took place, they had some information from a sample that was taken, and it gives the information here. And then it goes on to say that they took another sample after the fires, and it gave that information here. And it wants us to construct a 95% confidence interval for the difference of population means so that we can see what's going on with the number of trout. So because we're estimating means here, the difference of means, we are going to use either Z interval or T interval. Now we need to decide which one to use. And because we can see clearly in the problem that the population standard deviation is given to us and is known, that tells us we are going to go ahead and use 2 sample Z interval. So in order to use that, we need some information. So let's write down all the information that was given to us in the problem. For sample 1, this was for before the fires, and they give us that sample had 167, and then it goes on to say that the mean of the number of trout was 5.2 from that sample per day. And then it goes on to give us the population standard deviation for that, and that was 1.9. Then the second sample, this was after the fire. It gives us the information that the second sample was from 125 reports, and the mean from that sample, the average was 6.8 trout per day, and the population standard deviation was 2.3. So when we do this by hand, we need to find Z critical, and we also need to find the error. The error is going to be whatever we get for the Z critical times the square root of the population standard deviation squared over the sample size squared for each of the samples, and we add them together. We got to find Z critical, and because we're looking for a 95% confidence interval, I want to find what my Z critical is if 95% is between. We want to find these values of Z so that 95% lies between those two values. So we're going to use inverse norm for this. And I'm using inverse norm because we're using the normal distribution. Now, because 5%'s left over from the 95, and I know that some of it has to be in each wing here, and because of symmetry, I'm going to divide it equally into two. So each wing is going to contain 2.5%. So when I use inverse norm, I'm going to put 0.025 and 0.1 for my mean standard deviation for our standard normal distribution. What we're going to get when we put that in on the calculator is negative 1.96. So which means on this side of the interval, it's negative 1.96, and then on this side is 1.96. So our Z critical is going to be 1.96. When we're talking about critical values, we're really just looking about how far away from the center are we in terms of standard deviations. So we're 1.96 standard deviations away. We don't really care about whether it's on the left or the right side. We're just trying to define the distance from the center. So now let's put all this information in to find our error. So I'm going to put 1.96 for my Z critical, and I'm going to plug in all my information under the square root. So I'm going to put 1.9 squared over 167, and then I'm going to add that to 2.3 squared over 125. Now when you put that all on the calculator, you should get 0.50. So that's going to be our error. Now we're trying to estimate the difference between our means, and our point estimate is our x1 minus x2. If I take my x1, which is 5.2, and I subtract my x2, which is 6.8, what I'm going to get is negative 1.6. So I'm going to take my point estimate, which is negative 1.6, and I'm going to subtract my error. And I'm going to add my error, which we said was 0.5, to get my lower and my upper bound of my interval. When I take negative 1.6 minus 0.5, that's going to give me negative 2.1. And when I take negative 1.6 plus 0.5, that's going to give me negative 1.10. So my confidence interval is going to be negative 2.1 to negative 1.10. Now, if I were to interpret this, I would say we are 95% confident that the population mean of the catch per day before the fire was less than the mean after the fire. Now, the reason why I say that is because the mu1, which is our population mean for M1, which is the population mean for our first sample, and then minus the population mean for the second, because the difference of these falls between two negative numbers, mu1 minus mu2 has to be negative. And the only way that it can be negative, we discussed that, is that mu1 has to be smaller than mu2. So since this was before and this was after, then we know the mean before is less than the mean after for this confident interval. And remember, that means we're 95% confident. To find the confidence interval for this example on the calculator, we're going to go to statistic button, then we're going to go over to tests, and we're going to scroll down. And because this is two sample Z interval, we're going to choose this option right here, option number 9, and I'm going to hit enter. And this isn't from data that we're getting that we're entering into a list. I'm going to use the stat option. I'm going to put in my population standard deviation for each one. The first population standard deviation is 1.9. The second one is 2.3. The mean for the first sample was 5.2. The sample size for the first sample is 167. The mean for the second sample is 6.8. The sample size for the second sample is 125. We're doing a confidence level here of 95%, so I'm going to put in 0.95 here. I'm going to tell it to calculate, and here is what the calculator gives us. The calculator gives us negative 2.096 for my lower bound, and then negative 1.104 for the upper bound. We got, when we did it by hand, negative 2.1 and negative 1.10. That is a difference between rounding. So just make sure when you're doing this in your homework that you pay attention to the way that the question is worded so you round it correctly. Okay, in this second example, we have a doctor that is trying to determine if alcohol affects sleep patterns and brain waves. So you can read the example in more detail. I'm going to hop down to the information at the bottom. It goes on to explain that the doctor took a sample of 29 college students and divided them into two groups. And he gave one group wine before going to sleep, and the other group he didn't give any wine. And then he measured the brain activity. Group 1 was the group with alcohol, and group 2 had no alcohol. As you can see, no information was given or known as far as the population standard deviation. So because we do not know the population standard deviation, we have to use the t-distribution. So we have to find t-critical, and in order to find t-critical, we need to know the degrees of freedom. We also need to find the error, which we know to be t-critical times the square root of S1 squared over N1 plus S2 squared over N2. Now, as it was discussed before, if you want to find the degrees of freedom, there's a very complicated formula that you need to use. For our class, we're just going to do an estimate where we take the two samples and we look to see which one has the lower number of members in the sample and then subtract 1 from that. So since 14 here is the smaller of the two samples, our degrees of freedom is going to be 13. And just remember, when we do this using the calculator is going to give us the degrees of freedom based on that complicated formula. So our numbers are going to be a little bit different than what we get on the calculator versus what we do it by hand. Okay, so for T critical, we want to know what the T critical is if we're doing 90% confident, which means there's going to be 5% in each wing. So I'm going to do inverse T. I'm going to put in 0.05 in my degrees of freedom, which is 13. When we do that, I get negative 1.7709 and then some other numbers. I'm going to estimate T critical to be 1.771. I'm going to take that 9 and use that 9 to bump 0 up to 1. And of course, when we're talking about our critical values, we only use the positive value because we're only concerned about the distance from the center, not necessarily what side it's on. So I'm going to use T critical to be 1.771. Okay, so now we can calculate the error. So I have 1.771 times the square root, and I'm going to plug in all my information. My standard deviation for each sample, and my sample size. When we calculate that error and you put it in on your calculator, you should get 1.24. So I am going to use my point estimate, which in this case is x bar 1 minus x bar 2. I'm going to subtract the error. I'm going to add the error to find my upper and lower bound. Okay, so for my lower bound, I'm going to take 19.65 minus 6.59, and I'm going to subtract 1.24. For my upper bound, I'm going to take 19.65 minus 6.59 and then add my error. When I do that, I'm going to get that my confidence interval is going to be for my lower bound 11.82 and my upper bound is going to be 14.30. So that means my mu1 minus my mu2 has to be positive, which means my mu1 is greater than my mu2. So I'm going to state my conclusion here and say we are 90% confident that the population mean brain activity for the group with wine was greater than the population mean for the group without drinking wine. Okay, so let's check this on the calculator. This example, we use T distribution, and we're doing two samples. So I'm going to go to the stat button, over to tests, and I want to make sure that I use 2 sample t intervals. So that's option 0 right here. So 2 sample t interval. Make sure you're clicking on the right option. It's easy to make a mistake because they all look similar. So read it carefully before you hit enter. Again, we're not doing this directly from data, so I'm going to use the stats option, and I'm going to put in all the information. The mean from sample 1 was given to us as 19.65, and the standard deviation from the first sample was 1.86. The sample size from the first sample is 15. Now we're looking at the mean for the second sample, which is 6.59. The standard deviation for the second sample, which is 1.91. And then the sample size for the second sample is given to us as 14. Our confidence level is 90%, so put in 0.90. When it says pooled, just always leave it on no. That's a whole nother issue that we're not going to address in this class. So make sure that it says no. And I'm going to choose calculate. And the interval that's given to us from the calculator is 11.866 and 14.254. We got, when we did it by hand, 11.82 and 14.30, which is a little bit further off than what we normally are, and that is because we did an estimate of our degrees of freedom. We estimated it at 13, so that we don't have to use that detailed, complicated formula. But if we did use that complicated formula, the degrees of freedom are given here. It's actually 26.74 to 88935. So you can see it's far enough off that it's going to make a difference here. When you're doing the homework, I suggest just using the calculator, so you don't have to worry about using that complicated formula for degrees of freedom, and just use this as your interval. Okay, in this last example, we are going to look at the difference of proportions. And this example goes on to talk about a doctor that's doing sleep research again, but this time he's looking at rapid eye movement, and he's looking at the number of bad dreams. This is how he defines it here. Bad dreams by looking at fear, anxiety, and regression. And so he splits up 2 groups. He has one group where he has them watch a comedy movie before bed. And then in another group, before going to bed, he doesn't have them do anything. So then it goes on to give all the information here about the 2 groups. So let's go ahead and write this down. Let's see, we have our N1 is going to be 175. Our N2 is going to be 180. Now, it gives the number of successes. If we look at the number of successes, is the case where dreams with anxiety, fear, or aggression happen. If we consider that success, then our X1, and this problem is labeled as R1, but it's the same thing as X1. Our number of successes is 49. And in the second group, our number of successes is recorded as 63. So our P1 is going to be 49 out of 175. And our P2, which is our proportion, so that we have 63 over 180. Typically, I want you to keep it as fractions if you can, because it eliminates rounding issues. But these fractions work out where we don't have to round. 49 over 175 is 0.28, and 63 over 180 is 0.35 without any rounding. So that tells me that Q1, if I take the complement, is going to be 0.72, and our Q2, the complement of P2, is going to be 0.65. Now, when we look at setting up confidence intervals for proportions, typically we want to use the normal distribution to estimate, but we first have to verify that the sample sizes are big enough. And if you remember, to do that, we have to check that the sample size times P1 and Q1 is greater than 5, and the second sample is big enough by checking N2 times P2 and N2 times Q2 is greater than 5. You can verify that on your own. I'll let you do that, but I could tell you it does work. So we can go ahead and use the normal distribution to estimate. So we're doing a 95% confidence interval, and I need to find my Z critical, which means I need to figure out how far away from the center we're looking at. That can help me figure out my error. So here's my center, and I'm looking for my Z critical. How far away am I from the center? Since it's 95% confident, I know there's 2.5% in each wing. So I'm going to do inverse norm, and I'm going to put in 0.025, 0, and 1 for my percentile, mean, and standard deviation. And that's going to give me a negative 1.96. So that means our Z critical is going to be positive 1.96 because we don't include the negative with our critical values. Now I'm going to calculate my error. The formula for the error is Z critical times the square root P1 times Q1 over N1 plus P2 Q2 over N2, and then we square root it. All right, so let's go ahead and plug everything in and find our error. So I have 0.28 times 0.72 over 0.75 plus, and then I have 0.35 times 0.65 all over 180. I got to square root it and then multiply by 1.96. That's going to give me, when you put that in on the calculator, 0.096. So I've got to take my point estimate, which is P1 minus P2, and then I'm going to subtract my error. I'm going to add my error to get my upper and lower bound. If I take P1, that's 0.28, minus P2, which is 0.35, and I subtract 0.096, I'm going to do the same thing down here, but I'm going to add 0.096 for my upper. I'm going to get the interval goes from negative 0.166 to 0.026. So my population proportion for the difference of the two proportions is going to fall between these two numbers. Now, our conclusion is that we cannot draw any conclusions from this because we don't know if P1 and minus P2 is negative or positive from this, which means I can't compare P1 and P2. So there really is insufficient evidence here to draw any kind of conclusion. So I'm just going to write down, we cannot compare P1 and P2 in this case. Okay, now let me show you how to do this on the calculator. We're doing proportions, and we're doing it with two samples. So I'm going to click on the Stat button, arrow over to Tests, and I'm going to scroll down and find two sample prop Z interval. The prop is for proportions. So I'm going to hit Enter, and I'm going to put in all the information. Our first sample, we have X1 represents the success from sample 1. which we had was 49. And then our sample size was 175. Our successes from the second sample, that was 63. And our sample size was 180. We want to do a confidence level of 0.95 for 95% confident. And then I'm going to click on calculate, and it's going to give me the information here. So it gives me the interval from negative 0.1663 to 0.2634. When we did it by hand, we got negative 0.166 and 0.026. And again, you can see it's just a matter of how far out we went. And then it also gives us our proportions for each sample. Our proportion from sample 1 was 0.28, which we calculated that on our own. And our proportion from sample 2 is 0.35.